Right now, we're entering the most exciting era of space travel in decades, and humanity is standing at the edge of a new chapter. For the first time since the Apollo missions, we are not simply dreaming about returning to the moon. We are actively preparing to build a permanent presence there. NASA's Artemis II mission didn't just loop around the moon. It sent astronauts farther into deep space than any crew since 1970, testing the Orion spacecraft's life support systems and capturing rare, high-resolution images of the moon's far side. It marked the first time in more than 50 years that humans traveled beyond low Earth orbit, and it proved that our new spacecraft and deep space systems are ready for the next phase. And that moment was only the warm-up. Artemis III is preparing to return humans to the lunar surface, marking the beginning of NASA's long-term plan to build a permanent base at the moon's south pole. This mission is part of NASA's broader Moon to Mars strategy, a roadmap that envisions astronauts living and working on the moon for extended periods, supported by regular crew rotations, commercial landers, and a network of surface habitats and power systems. The South Pole is the key to all of this. Inside its permanently shadowed craters lies frozen water ice, a resource so valuable that it could transform the moon into a fully self-sustaining outpost. Water can be split into hydrogen and oxygen, creating breathable air, drinking supplies, and even rocket fuel. If humanity can master the ability to extract and use lunar ice, the moon becomes more than a destination. It becomes a refueling station for the entire solar system. But this new era isn't defined by one nation. China is rapidly expanding its lunar program and has laid out a detailed roadmap for the International Lunar Research Station, a long-term robotic and eventually crewed base planned for the 2030s. Russia remains a core partner in the project, and the ILRS coalition continues to grow as more nations sign on. India is preparing to join the crewed spaceflight club with Gaganyaan, its first human-rated spacecraft, marking a major step in its deep space ambitions. For the first time in history, multiple nations aren't just racing to reach the moon. They're racing to stay there. More than 60 countries have signed the Artemis Accords, aligning themselves with NASA's vision for peaceful, transparent, and cooperative exploration. Others have joined China and Russia's ILRS initiative. In total, more than 80 nations now operate space programs or participate in lunar efforts. The moon has become the center of a global competition: scientific, strategic, and economic. NASA leadership has made it clear that this new chapter is about more than flags and footprints. The moon is now a strategic frontier, and officials have stated that the United States will not give up the moon again, reflecting concerns that China's rapid progress could give it a long-term advantage. This brings us to the next phase: building the bases themselves. NASA's Artemis Base Camp concept outlines a long-term surface presence that includes habitable modules, pressurized rovers capable of multi-day journeys, unpressurized rovers for cargo transport, and power stations designed to operate through the 2-week lunar night. NASA is developing technologies that can extract oxygen from lunar regolith, melt and purify ice, and convert water into fuel. One of the most ambitious projects is NASA's plan to deploy a 40-kilowatt nuclear fission reactor on the moon, a compact, durable power source capable of running habitats, mining systems, and scientific equipment regardless of sunlight. This reactor, part of the Fission Surface Power Project, is designed to operate continuously for at least 10 years, providing the stable energy needed to support a permanent human presence. NASA is also exploring the possibility of building structures using lunar regolith itself. Instead of transporting heavy building materials from Earth, future astronauts may use 3D printing systems to melt and fuse lunar soil into bricks, landing pads, radiation shields, and even entire habitats. This approach, known as in situ construction, could dramatically reduce the cost of building a lunar base and make long-term settlement far more practical. Some experimental designs even propose burying habitats beneath layers of regolith to protect crews from cosmic radiation and micrometeorites. NASA has already tested regolith-based construction techniques on Earth using simulated lunar soil, and early results suggest that large-scale structures are entirely feasible. Although NASA originally planned to build the Lunar Gateway as an orbiting station around the Moon, the agency has shifted its immediate focus toward direct surface infrastructure. Gateway remains part of the long-term architecture, but the priority is now on establishing a functioning base on the ground as quickly as possible. This shift reflects a broader strategic goal: to create a permanent human presence on the Moon that can support scientific research, resource extraction, and preparation for missions to Mars. China and Russia's ILRS blueprint mirrors NASA's approach in many ways. Their proposed base includes laboratories, communication systems, power infrastructure, and eventually crewed habitats. Early robotic missions in the late 2020s will scout landing sites, test construction methods, and begin laying the foundation for a human-capable outpost in the 2030s. China has also announced plans for a nuclear power plant on the Moon by 2035, which would support long-term operations and scientific activity. Both NASA and the ILRS envision the Moon as a hub for science, industry, and exploration. Mining lunar resources, producing fuel for deep space missions, and testing technologies for Mars are all part of the long-term strategy. The Moon is no longer the finish line, it's the launchpad. Once we settle on the Moon, the next logical destination is Mars. But Mars is a far more challenging world. It has a thin atmosphere, extreme temperature swings, and high radiation levels. Terraforming, while theoretically possible, is far beyond our current capabilities. Even establishing a small, self-sustaining outpost will require breakthroughs in radiation shielding, agriculture, and closed-loop life support systems. The Moon will serve as the proving ground for these technologies, allowing humanity to test everything from habitat construction to resource extraction before attempting the journey to Mars. Beyond Mars lies an even greater frontier: the thousands of exoplanets discovered across the galaxy. Some of these worlds sit in the habitable zones of their stars, where temperatures could allow liquid water to exist. While interstellar travel remains far beyond our current capabilities, the discoveries made by telescopes like Kepler, TESS, and the James Webb Space Telescope have shown us that potentially habitable worlds are far more common than we once believed. The Moon is the first step, Mars is the second, and beyond that, the universe is full of possibilities, which we will explore in the next video. Thank you for watching. If you enjoyed this, please like and subscribe for more.